Hello, I'm Dr. Christopher Tucker of Cartheur, and today I'd like to introduce our wireless charging station. This is a concept that we're working on for mobility, personal mobility, specifically scales smaller than the automobile. So currently, people are very tired of polluting machines, stinky diesel cars, wearing masks in capital cities, having to march because coal plants are polluting the environment. So we as a population are becoming more conscious of these things that are contributing to problems in our health. So we don't want this anymore. So what are we going to do? Let's work on mobility, work on electric bicycles, electric scooters, anything that's smaller than an automobile, but it works just for you as a person. So the concept we have here is a wireless charging station. So the idea is that you have a bicycle, you take it to a station, you have with an application, tell the station what it is, what kind of a charging setting you want, a high, a medium, or a low. And in combination with the battery that we have, you get a second selection of an optimization function or a maintenance function. So in all, there are 5 specific settings on the station. The station, in model form, looks more or less like this. We're demonstrating on an Arduino, an Atmel driven system for a controller. We have a single cell LiPo battery that has a controller board and the AC to DC conversion system with some lamps here that will show you the different positions. So we have high, middle, and low of the different colors. So let's go have the demonstration here. So on the side here that you can see the antenna, but you can't see the back, is our proprietary transmission system. This transmission system is functional, and I can show you that by this lamp here, that it's functioning. So the station itself is transmitting power. So let's say you come in and you want to charge up. Let's bring this in close, right, for now. Now let me open the software on my laptop here and show you how it works. So the software will connect up to the controller board and allow me to pick some different selections. So let me select the highest charging. And what that means is, so I'm on my bicycle and I'm going around the city, going in, say I'm in the center of any capital city, and I want to drop my bicycle in my station, do a very short charging cycle because I'm going shopping or maybe I'm having a cup of coffee, so I want to do that very much. So let's set the high function. It takes a few moments for it to load up. You can see here that the green light is lit, the green lamp is lit. You can also see that the red LED here on the controller board is telling you that the battery is charging. So if I take this away a bit, you can see how, okay, now it's not charging, now it is charging. Yes. We also have the middle setting, right? So I want a medium charge. So I want a cup of coffee, and maybe I want to go shopping, see some friends. So I want to spend a little less money on my charging, so I can set this to the middle function. But again, as you see, now I have the middle light lit, and the controller board is still lit, showing that the battery is being charged. Now let me go to the lowest function. The lowest setting, now what that means is that I'm going to work today, so I'll be in my office all day. So I have 8 hours, so it doesn't matter to me how long the bicycle sits in the station, so I'm going to pick the most economically cost-effective solution to charge my bicycle while I'm at work. And again, you can see it functioning here as well, again, charging the system. So that a less amount of current is going into the battery for the charge. The voltage is staying the same, but the current is remaining less. So that's how that would do that. For the middle settings, and I'll just go over one of them because we have two mid settings we talked about. We talked about maintenance, we talked about optimization. So looking at the maintenance function. So the maintenance function is an idea that allows some programming to take place on this chip here. So in terms of the battery, you have routines that can help with how the electrolyte levels are occurring in the battery. And this is a separate product that is not detailed here, but that's what these positions are here for. There's also a second function, which I will demonstrate quickly, that shows an optimization function. That shows these here. And it also shows you the lamp position of what it would look like that is presented to the user. What you can't see on the camera here is the software system that is running on this laptop. It's just Windows 7. It's currently a desktop application, but could be a web application. It's not a problem. We also have an interesting feature. So say somebody breaks into the system or does something funny with it, right? So if any threat detection or security or vandalism that takes place, we have alarms that can take place. Or else perhaps your bicycle's not sit properly on the station, right? So we have that. So the idea of the system is to work within the infrastructure of the cities. We are currently working with a set of partners who are manufacturing bicycles and manufacturing batteries, and are looking for alternate solutions to the status quo. So I've noticed personally that when people go to different charging stations that have to try to fit different types of plugs because of the lack of standardization currently, that becomes very confusing and frustrating for the user. So the idea of this particular system is to say, let's just create a standardization for all bicycles that carry an antenna and have a type of battery that is compatible to the system and who can use it anywhere in any city, anytime. You can travel to the entire world. Well, that's a demonstration of our wireless charging station, or the bunny hop system. Thank you for watching.